Good morning, class. I am Teacher Maan, and I am very excited to be your teacher in Earth Science. I hope that you and your family are in good health in this time of pandemic. Today, we will discuss the most essential learning competencies or MELCs that you need to master. Number 1, describe the characteristics of the Earth that are necessary to support life. Number 2, explain that the Earth consists of 4 subsystems across whose boundaries matter and energy flow. At the end of this discussion, you are expected to understand the nature of earth science, identify the different branches of earth science based on the 3 basic component disciplines of modern earth science, give the importance of earth science on different fields, describe the characteristics of the earth that are necessary to support life, identify the factors that allow a planet to support life, and describe the Earth subsystem. When you open your module on page 4, the pre-assessment is given to measure your prior knowledge. The score is recorded but not graded. So, do not worry if you get a low score. Let us continue. What's new? I have a poem here and I want you to analyze the meaning. The title of the poem is One Earth, One Chance. Let me read the poem. Earth is the only planet habitable to all organisms, a sanctuary of all living and non-living things. The only place we can say home. Take care of it, for it will take care of us. Now, question. What is the poem all about? Another question. In your own words, explain how do you value our planet? Take time. Let us discuss now. Brief history of earth science. The origin of the earth science lies in the myths and legends of the distant past. The creation story, which can be traced a Babylonian epic of the 22nd century BC, which is told in the first chapter of Genesis, proved to be the most influential. The story is cast in the form of Earth's history and thus was readily accepted as an embodiment of scientific as well as the theological truth. Earth scientists later made innumerable observations of natural phenomena and interpreted them in an increasingly multidisciplinary manner. The earth science, however, were slow to develop, largely because the progress of science was constrained by whatever society would tolerate or support at any one time. Continue reading in page 8 and you will answer the following guide question. Number 1 guide question. What are the branches of earth science? Number 2 question. What are the importance of studying atmospheric science? Number 3 question. What is the importance of studying hydrologic science when it relates to water resources?
What are the branches of earth science? We have atmospheric science. Next, hydrologic science. And then we have geologic science. Atmospheric science has many branches. One is the aeronomy. It is the study of the atmospheric regions above the lower stratosphere. It deals with the phenomena such as air glow, auroras, and photochemical processes. Another branch, we have climatology. It has something to do with the long-term weather conditions on a global scale. Next is the meteorology, primarily concerned with the short-term weather variations in the atmosphere. Atmospheric science has an importance. One of the importance is the weather forecasting. It could give accurate predictions of the future weather conditions. Another is weather modification. To modify the weather, such as suppressing the hail and fog and weaken hurricanes. Hydrologic science has branches. It is the study of the Earth's bodies of water. In its widest sense, hydrology encompasses the study of the occurrence, the movement, the physical, and chemical characteristics of water in all its forms within the Earth's hydrosphere. Hydrologic science has many branches. One is the engineering hydrology. It concerns with the design of man-made structures that control the flow and use of water. Next is the glaciology, the study of glaciers and ice caps. Another is the groundwater hydrology. Focuses on subsurface water in the unsaturated zones. Next, we have hydraulics, concerned with the dynamics and mechanics of water in its liquid state. Next, we have hydrography, description and mapping of the bodies of water of the Earth's surface, including the Earth's with a particular concern on the navigation chart. Next, we have hydrology, the study of water on and within the ground. We have hydrometeorology, focuses on water in the lower boundary of the atmosphere. We have hydrometry, involves measurement of the surface water, particularly precipitation and stream flows. We have limnology, study of the lakes and inland seas. We have soil water physics, study of subsurface water in the unsaturated zones. Another, we have oceanography. It is the study of oceans and seas. We have physical oceanography, chemical oceanography, submarine geology, and biological oceanography or marine biology. Importance of hydrological science, development and management of water resources, concern for groundwater quantity and quality, and prevent drought and other climatic patterns. And then we have geologic science and its branches. Disciplines concerned with the physical, chemical makeup of the solid earth. Different branches are astrogeology. Its study of rock record on the moon, planets, and their satellites. We have economic geology, study of mineral commodities in which modern civilization is heavily dependent. We have engineering geology, concerned with the engineering properties of geologic materials, including their strength, compactability, and permeability, and the influence of these properties on the selection of locations for buildings, roads, and railroads, bridges, dams, and other major civil features. We have also geochemistry, the study of chemistry of rocks. We have geochronology, study of the isotonic chemistry and age-dating rocks. We have geomorphology, study of landforms which is concerned with the description of the features of the present terrestrial surface and an analysis of the process that gave rise to them. We have geophysics, study of physical properties of rocks at the Earth's surface and interior. We have mineralogy, study of minerals, paleontology, study of fossils and fossil records, pedology, study of soil, petrology, study of rocks, seismology, study of earthquakes, structural geology, study of the structures in the solid earth, and volcanology, study of volcanoes. We have some importance: exploration for accumulations of fossil fuels, earthquake prediction and control, and last, selection of locations for buildings, roads, railroads, bridges, dams, and other major civil features. And these are the importance of geologic science. What makes the Earth suitable for life? Number one factor: our Sun is a stable and long-lasting star. It sustains the energy that the Earth needs. Number two, our planet has water. Number three, we're at just the right distance from the Sun. And number four, we have an ozone layer in the atmosphere to block harmful rays. You can also give other factors that makes the Earth suitable for life. Now, let's move to the Earth subsystems. The Earth consists of 4 subsystems: a crust whose boundaries, matter, and energy flow. These subsystems include the lithosphere, known as the solid portion of the Earth, the atmosphere, known as the gaseous surrounding of the Earth, the hydrosphere, the ice, water, and water vapor or near the Earth's surface, and the biosphere, the zone at or near the Earth's surface that supports life. These subsystems of the Earth interact with each other, and these 3 subsystems are independent and have their respective mandates or functions. Each can only succeed if all 3 subsystems are able to perform their respective functions. The Earth system is essentially a closed system. It receives energy from the Sun and returns some of this energy to space. Let's have the atmosphere. The atmosphere is the thin gaseous layer that envelops the planet. It is also where the weather and climate occurs. It is composed of gas layers that serves as protection from ultraviolet radiation and extraterrestrial objects like asteroids. The present atmosphere is composed of 78% nitrogen, 21% oxygen, and 0.9% argon, and a trace amount of other gases. One of the most important processes by which the heat on the Earth's surface is redistributed is through atmospheric circulation. There is also a constant exchange of the heat and moisture between the atmosphere and the hydrosphere through the hydrologic cycle. Next is lithosphere. The lithosphere is the solid part of the Earth that includes the rocks of the crust and mantle, the metallic liquid outer core, and the solid metallic inner core. Plate tectonics plays an important role shaping the surface of the Earth. The primary driving mechanism is the Earth's internal heat, such as that in mantle convection. Next sphere is biosphere. The biosphere is the set of all forms on Earth. It covers all ecosystems, from the soil to the rainforest, from mangroves to coral reefs, and from the plankton-rich ocean surface to the deep sea. For the majority of life on Earth, the base of the food chain comprises photosynthetic organisms. During photosynthesis, carbon dioxide is sequestered from the atmosphere, while oxygen is released as a byproduct. The biosphere is a carbon dioxide sink, and therefore an important part of the carbon cycle. The fourth sphere is the hydrosphere, a dynamic mass of liquid that is in constant motion, evaporating from the surface and bodies of water to the atmosphere, and will be back in the form of precipitation running inland, bodies of water, and oceans again. About 70% of the earth is covered with liquid water, and much of it is in the form of ocean water. Only 3% of Earth's water is fresh. 2/3 are in the form of ice, and the remaining 1/3 is present in streams, lakes, and groundwater. The oceans are important sinks for carbon dioxide through direct exchange with the atmosphere and indirectly through the weathering of rocks. Heat is absorbed and redistributed on the surface of the earth through ocean circulation. Class, you can still read your module at your most convenient time and message me if there are parts that you do not understand. After doing that, I think you are now ready to answer activities and assessment on this module. On what's more, do independent activity 1, hunt me as you find me on page 14. Answer independent assessment 1 on page 15. Do independent activity 2 on page 15. Answer independent assessment 2 on page 16. Do independent activity 3 on page 16. And answer independent assessment 3 on page 17. After doing that, to sum up the lesson, you should do the what I have learned part of the module found on page 18. For the practical application of the lesson, you answer the problem on the situation given on page 19. To evaluate your level of mastery in achieving the learning competency, answer the 20-item assessment on page 20. To enrich your knowledge or skill of the lesson learned, you also answer the activity on page 23. After doing this, let your parents submit the ADM module and accomplish answer sheets in your respective barangay where I will collect it. Thank you and enjoy learning. Stay at home and keep safe. God bless everyone.